Raptor tread drive? Raptor what? Track drive. Damn it. This year, the ZouKeepers were sponsored by AndyMark, and they provided us with the Raptor Track Drive, and it is a tank tread drive, and it's pretty ideal for this year's game because the tank treads allow us to remain in full contact with the step during the end game.
For the intake, we are using 2 4-inch Omni wheels and 4 2-inch Omni wheels with the green 35 durometer wheels. The intake is powered by a 775 Pro with a 75-to-1 gear reduction versus planetary gear reduction. We use bigger Omni wheels on the outside and smaller Omni wheels on the inside in order to center the ball in our intake. With this slanted design, it allows the ball to come in from almost any angle, about 180 degrees around. And as soon as the ball makes contact with our Omni wheels, we have control and it gets sucked right in. The wrist on the robot serves 2 purposes. In the up configuration, the piece of Lexan with the Velcro facing out allows us to pick up hatches from the feeder station, as well as place the hatch panels on the rocket and the cargo ship. We use pneumatic cylinders in the face of this panel to detach the hatch panels from our robot. The wrist uses a pneumatic cylinder to fold 90 degrees forward into our cargo intake mode. In this mode, we can intake cargo and transport it to the rocket or the cargo ship. For the arms, we decided to use a 4-bar linkage. This allows the mechanism on the front to remain facing forward the entire time throughout the motion of the arms. In order to move the arms, we used 2 sim motors with an overall ratio of 196:1. In order to get feedback on the angle of the arms, we first used potentiometers. It wasn't until after we mounted them and started messing with code that we realized they were 10-turn potentiometers, and the feedback from them was too coarse to use. At which point we switched to encoders, which gave us 2,500 ticks throughout the entire movement of the arm. We used the Talon SRX to control the motors for the arm. We used the closed loop position built into the Talon SRX to control the movement of the arm. Initially, we had problems with the motors binding up when we tried lifting up the arm. This was due to the output shaft of the motors getting cantilevered from the torque applied by the arms. We added bracing on the ends of the output shafts to keep it perfectly collinear with the motor and gearbox. This reduced all problems and now functions perfectly. In order to tension the chains, the bar that both motors are mounted on moves up and down. Each end of the bar has 4 bolts in it. These bolts are tightened in order to tighten the chain. As the bolts are tightened, the entire bar gets pulled directly downward. In order to climb with this robot, we decided to only go for the middle 6-inch step. To climb, we used a single piston in the back of our robot to lift one end of the robot up. We added an Omni wheel on the bottom of the piston so that when we're in the lifted position, we can still drive around. This allows us to lift up, drive forward over the edge of the platform until the edge of our tracks is hovering over it. At which point, we lower the piston and our tracks are touching the top lip of the platform, and we just drive right up. We added these 12-pound weights each in the back of the robot to help tip the robot back over after we get up on the platform, on the middle platform. These blocks also helped balance our robot when our arm was all the way up in the air. This entire robot is completely stable, and we have had no issues with toppling.
Thanks for watching. Like and subscribe. Bam.